All right. Hey guys, we are going to be continuing on with statistics today. You will be needing your calculators. So hopefully you have the one that you got for school or the one that the school lent you. Or if you don't have a calculator, I posted a link to the software for your computer. So hopefully you can get it on a computer or a laptop and you can follow along on the calculator. All right. If you don't have a calculator for whatever reason, you need to let me know, and I'm not really sure what's going to happen if you can't get a calculator, but you will be needing one, right? And you will need it for the next test, and you'll be needing it for your homework. So make sure that you either download the software or you find your calculator, and if you can't, let me know. All right. So before we use the calculator, let's do this warm up. It's based on box plots, which we did in the last lesson. So go ahead and pause the video and try answering these first 3 questions. All right, so hopefully pause the video. Let's take a look. The box plots below show the distributions of maximum speed for 145 roller coasters in the United States, separated by wooden versus steel roller coasters. All right, so which type of coaster has more observations, has more speed measurements? So we know they measured 145 roller coasters total. Well, how many wooden ones and how many steel ones are there? Well, you can't tell, right? Because this just tells us like how spread out the data is. It doesn't tell us how many roller coasters were measured. Right? I think a lot of you are going to say the steel roller coasters because this looks a lot wider. Right, it goes from about 30 miles per an hour to 100 miles per an hour, right? But that doesn't mean there were more steel roller coasters measured. It just means there's a wider range in their speeds compared to the wooden roller coasters. So you can't tell. Can't tell. Right, so I'm just going to add an extra note, even though there is a wider range of speeds for the steel roller coasters. Steel roller coasters. That does not mean more does that mean more measurements? Right? We don't know how many steel roller coasters they measured. Maybe steel roller coasters just have a very big difference in speeds, right? Doesn't mean there's actually more measurements of steel roller coasters in this data set. All right, hopefully that makes sense. That's a really important concept when it comes to box plots. Also, number 2, which type of coaster has a higher percentage of coasters that go 60 miles per hour? Justify your answer. Well, if you look at steel roller coasters, 60 is the median, right? That is the 50th percentile, right? The halfway point if you order everything from least to greatest. Well, that means around 50% go faster than 60 miles per hour. So I'm just going to compare for steel. It's about 50%. Let's check for wooden. So 60 miles per hour, that looks to be around the 3rd quartile, right? Again, that's 60. That there is Q3, which is the 75th percentile. So that means only 25% of roller coasters go faster than 60 miles per hour for wooden coasters. So which one has the higher percentage? That is going to be steel. Right? Because about 50% of steel roller coasters go faster than 60 miles per hour, whereas only 25% of wooden coasters go faster than 60 miles per hour. So it has a higher percentage, right? I don't want to write all of that out, but that is how you could justify your answer. Number 3, which type of coaster has a higher percentage of coasters that go faster than 50 miles per hour? Justify your answer. All right, so now let's look at 50 miles per hour. And that looks to be the 1st quartile. for steel, right? So that is the 25th percentile, which means 75% of roller coasters, right? Here's 25%, here's another 25%, here's another 25%, right? That's 75% of roller coasters go faster than 50 miles per hour. And that looks to be around the same for wooden roller coasters, right? That looks to be about 50 as well. So the same. Both types have about 75% of their coasters go faster than 50 miles per hour. Right? We can say, if you want to add a little bit more, 50 miles per hour is the first quartile for both. All right. There we go. So here's a fun little question about mean, right? Mean, median, and mode. So mean is the average, right? What you get when you add all of the values and divide by the total number of values. So the mean weight of 3 dogs is 38 pounds. One of the dogs, Sparky, weighs 46 pounds. The other 2 dogs, Eddie and Sandy, have the same weight. Find Eddie's weight. Which one is Sparky? All right, this guy right here, that's Sparky. So Sparky weighs 46 pounds. And the other 2 dogs, Eddie and Sandy, have the same weight. So let's say this one is Eddie, this one is Sandy, and they have the same weight, so I can call both of them X number of pounds. Let me make my arrows go the same way, because why not? So think about how we can find Eddie's weight if we know the average of these 3 dogs' weight is 38. All right, so again, average is the sum of all their weights divided by the number of dogs, which is 3, right? So the mean, or the average, is going to equal 38 plus the weight of Eddie, which I don't know, I can call X, and the weight of Sandy, which is also X because they weigh the same, right? They have the same weight. So therefore, I can call them both X number of pounds. So this average, I divided by 3 because I added up 3 weights together. And it says the mean weight of all 3 of these dogs is 38 pounds. And I'm sorry, this 38 should be a 46, right? The weight of the first dog was 46, not 38. The average is 38. So when I add up those 3 weights of those 3 dogs and divide by 3, I get the average, and their average is 38. So all we're doing is solving this simple equation. So 46 plus 2x over 3 equals 38. Right, if you want to solve this equation, we're going to multiply both sides by 3, right, to get rid of the fractions. And we get 46 plus 2x equals 114. Minus 46 on both sides, and divide by 2. So what is 114 minus 46? 3268, I believe. And so each one of those other 2 dogs weighs 34 pounds. So we literally just used the definition of average or mean, which is the sum of everything divided by the total number, and that equals the average, which was 38. All right, so hopefully not too bad there. And so let us move on now to the calculator portion. So how can we use our calculators to find the 5-number summary and other information? So the 5-number summary we talked about last lesson, right? Those are the things you need to create your box plot. That's going to be the minimum, first quartile, the median, the third quartile, and the maximum value. So the data below shows the number of pets owned by students in a small poll. Write down the 5-number summary of the data above using your calculators and convert to a dot plot and convert the dot plot into a box plot. So minimum, Q1, first quartile, the 25th percentile, right? The median, the 50th percentile, the third quartile, the 75th percentile, and the maximum value is what we're looking for. And this would actually be pretty simple to do by hand, right? We could write out all the numbers in order 0, 0, 1, 1, 1, 2, 3, 4, 5 twos, 2, 2, 2, 2, 2, right? You can list out everything, find the median of the lower half, find the median of the upper half, right? To get all our values like we did last time, but I want to practice using the calculator today. So I'm going to go ahead and switch screens, and please, 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 please follow along on your calculator and actually do this, right? Otherwise, you will be lost when you actually have to do it yourself. So on the calculator, I have steps in that box to the right. Step 1 says type in all of your data on a lists and spreadsheets page. Make sure to name your data on the top cell. So if you haven't turned on your calculator in a while, here it is. We're going to be adding a list and spreadsheets page, which is not that. It's going to be this one, right? You go right there, list and spreadsheet. If you go to new document, you can also add from here, list and spreadsheet. So it's going to look like an Excel page, and it even has the same color. It's green. So you have to hit the up arrow 2 times, go up here, right, or click here, and we're going to name our data. So this was number of pets, so I'm going to call it pets. And by the way, you can't have any spaces in this naming, so don't put a space in your name. Just call it one word. I called mine pets. And now I'm going to type in all of my data. So I notice there's 2 dots above 0. So there are 2 people with 0 pets. So you type in 0 2 times, and then you type in 1 2 times. And then there are 5 2s. So type in 2 5 times. So hit 2, enter, 2, enter, 2, enter, 2, enter, 2, enter. You can hit the down arrow key. So 1 2 3 4 5. 1 2 3 4 5 3s, 3 4s, 2 5s, and a 6. All right. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. So what I just did is I double checked. I noticed I am at cell number 20 now. So I just counted all the dots to make sure I typed in all my data, right? So I had 20 points on the dot plot. Make sure you go to the 20th cell. And so that is step 1. I typed in all of my data into the calculator. So to get the important numbers, it says step 2, add a calculator page. So we hit Control Doc, right? You'll see when you hit Control Doc in that blue, it says plus page. So we're adding a new page, right? And so add a calculator. So now we're on a new calculator page. And by the way, you can go back, right, to your old page by clicking up here. You can also hit Control Left and Control Right to navigate through your pages. You can also hit Control Up, and you'll see all of your tabs that are open. All right. So anyway, on the calculator page, go to Menu. The topic we are in right now is Statistics. So go to Statistics. Then go to Stat Calculations, which is the first one, and 1 Variable Stats. All right. So for the number of lists, well, we typed in 1 list of data, right? So it's 1. And hit OK and select the name of your data under X1 list. So X1 list, aha, it's right there, right? That was what our list of data was called, pets. And that is all you need. Don't change anything else. And hit OK. And there we go. There is all of our data. I'm actually going to take a picture. Hopefully all that fits. And let me add it onto my iPad. Use photo. But I'll tell you what all of these things mean in a second. All right, so on this page, it gives you this thing, this symbol, X with a little bar over it. That is the mean. The mean is 2.75. That is the average. All right, ignore all of this for now. We'll talk about some of this stuff later. On this N is the number of data values we have, which is 20. Min, well, I think you can figure out that is the minimum. The minimum value here is 0. the first quartile, Q1, is 2, the median is 3, the third quartile is 4, and the maximum value is 6, right? And don't worry about any of the other stuff yet, right? So all of this stuff I'm highlighting, you don't need to worry about. We'll talk more about that later. And that is how you can do stats in your calculator, right? So the directions are right there if you ever get confused. You can also rewatch this video, all right? For homework, make sure you are following the same steps yourself. And once you type it into your calculator, you do one variable stats on a new calculating page, and you get all of this information. So that represents the mean. All right? And then the rest is self-explanatory, right? That's the minimum. That's obviously the first quartile, median, third quartile, and the maximum. And this n, that is the number of data values. So in this case, we inputted 20 data values. And so 0, 2, 3, 4, 6. 0, 2, 3, 4, and 6. Cool. All right, your calculator can even do fancier stuff than that. So let me go back to my calculator again. And so hopefully this is casting. All right, looks good. So also in that box on the notes, it says to see a dot plot or box plot of your data, what we're going to do is we're going to add, so control doc, we're going to add another page. We're going to add a data and statistics page this time. So click that. And then it says click to add your X variable to the bottom. So it depends what kind of calculator you have, but it'll say click to add variable here and here. We're going to add our variable down here to the bottom. So click that, and you'll see the name of whatever you named your data will appear here. So you hit that, and it says pets. And wow, look, it's the dot plot, and it looks exactly like the dot plot we have in our notes, correct? If you go to menu, and you go to plot type, we can also make this a histogram or a normal probability plot, which we will not be using. We can also make it a box plot. So histograms we will be doing later, but that's a histogram. You can also make it a box plot, which is what I wanted for this problem. So another way to get the minimum, 0, first quartile 2, median 3, third quartile 4, and maximum 6 is by looking on here as well, and you can get all of that same info. So pretty cool. All right, so it says convert to a box plot. I don't feel like redrawing it, so I'm going to just take a picture of this, and that will be my box plot. All right, so getting back to my iPad. Boom. Come on. All right, there we go. So that's the box plot. And again, minimum, first quartile, median, right, Q3, and maximum. So hopefully you could draw that out yourself, right? Make a number line on the bottom, and that's it. All right. So here is another one to practice. All right, so example 1, quiz grades. I highly recommend trying this yourself, right, before watching the rest of this video. So go ahead and pause and try doing this one on your calculator as well. All right, so let's do it. Here is a list of Miss Melville's 25 students' recent quiz grades. Create a dot plot of this data. Use your calculator, data, and stats page. All right, again, we don't have to do this on the calculator. I just want you guys to practice using your calculator because it will help. And by the way, I would definitely make a new page. So I'm going to delete all of this. So do not save. All right, hit the on button, go to new, don't save, and I'm going to start fresh. So add another list and spreadsheet. I'm going to call this quiz grades, all as one word, no spaces. and type in the data. So 8, 6, 10, 8, 7, 9, 9, 8, 9, 6, 10, 10, 9, 2, 7, 9, 8, 10, 9, 9, 3, 9, 10, 7, and 10. And 25 students. I ended at the 25th cell, so that looks good. Right, add a page. So it's just make a dot plot. So data and stats page, click down here, quiz grades, and that took me about 10 seconds to do that. So there's my dot plot. I'm just going to copy onto my notes. All right, so I am doing it on the computer, so I can do it probably a little bit faster, but it shouldn't take too long on your personal calculators user. All right, so I've copied all of that onto my notes, right, that dot plot. And what do you think are the outliers? So outliers are extreme values that do not fit in with the rest of the data. And based on these results, I would definitely say 2 and 3 look to be outliers, but we still don't know for sure what an outlier is, but I think 2 and 3 are outliers. Right. I don't think we ever defined what an outlier is. So outliers are extreme values that lie far away from most of the data. So we could have data values that are extremely low or extremely high, right? If you had someone get like a 20 on this quiz, even though 10 is probably the maximum grade. But if somehow some people got 20s on this quiz, those would probably also be outliers, all right? Fill in the 5-number summary for this data and use it to complete a box plot. Use your calculator again. I guess I will show you this on the calculator. So again, on the calculator, we can hit Control Add Page, Control Doc, right? Add a calculator page. It goes Menu, where we are doing statistics, stat calculations, choice 1, one variable stats. You hit OK, and then you go to your X list. If you did not make a new page, you'll also see pets here, right? Just go to quiz grades, hit OK, and there is our 5-number summary right there: 2, 7, 9, 9.5, and 10. So let me go back one more time to my iPad, and let's write that down. So minimum 2, first quartile 7, median is 9, Q3 is 9.5, and the max is 10. All right. So if I make this box plot right now, right, I would plot all of these values over here. But I'm sorry to keep switching back and forth, but let's go back to the calculator one more time, and let's make a box plot on our calculator and see what happens. So back to this calculator, I'm gonna add a page and add another data and stats page. You can also go back to the original one, but I'll make a new one. So we have this, go to Menu, Plot Type, and let's make this a box plot. And then when I make this a box plot, notice how normally don't we extend these whiskers, right, to the minimum? But notice how it stops at 6. So 6 is what it's saying is the minimum, and it's leaving these two guys out as dots because these are actually outliers, right? 2 and 3 are outliers. Your calculator automatically excludes these values in the main box plot because it considers 2 and 3 an outlier. So let me show you how to do this or draw this on your notes. So what I like to do is when values are outliers like that 2 and 3 is I like to make a little asterisk, right, a little star shaped thing on 2 and 3 to point out that we have 2 outliers at 2 and 3. All right, and then the rest of this goes as normal. So the next lowest value after 2 and 3 is 6. So I draw a dot at 6. My Q1 is at 7. My median is at 9. Q3 was 9.5, and the max was 10. So here's my 2 ends. the middle 3 points are going to be our box, right? From there to there, right? That is our interquartile range, right? Q3 minus Q1. So that's where the box goes. Our median right there. And there it is. So these two guys represent outliers. So what do you notice happens on the calculator? Why do you think this happens? So on a calculator, again, I showed these two as dots, right? It shows outliers as points not included in the box plot. So when you do draw a box plot, make sure you do include the outliers, though, as part of your graph. So what exactly is an outlier? So here it is. Here is the definition. An outlier is a data point that differs significantly from the other observation. So what is a significant difference? This is where they define it. An outlier is any data point that is more than 1.5 times the IQR below Q1 or above Q3. All right, so let's decipher this. Let's figure out what 1.5 times the IQR is first. So again, the IQR, interquartile range, is equal to the third quartile minus the first quartile. So in our example over here, the third quartile was 9.5 and the first quartile was 7. So our IQR is 9.5 minus 7, and that's equal to 2.5. Right, so what that means is there is a difference of 2.5 here from our first to third quartile. That's our IQR. Next, show 1.5 times the IQR, and that is equal to 2.5 times 1.5 is 3.75. So anything that is 3.75 below Q1 or above Q3 would be an outlier. So Q1 minus 3.75, anything less than this number would be an outlier. So Q1 was 7. So 7 minus 3.75 equals 3.25. So what that means is any value below 3.25 is an outlier. All right, and that is just the definition people use in statistics for what an outlier is. 1.5 times below Q1 is an outlier. So what we did is 1.5 times the IQR, we got 3.75. So anything 3.75 below Q1 is an outlier. So I did Q1 minus 3.75, I got 3.25. Anything below that number is an outlier. I know we don't have any outliers above, but let's just do the same thing. Right, anything that is Q3 plus 1.5 times the IQR, which is 3.75. Anything above this number would be an outlier. So what was Q3? Q3 was 9.5. So 9.5 plus 3.75. What is that equal to? What is that equal to? 12.5. What is that? 13.25. Right. If there were any quiz grades above 13.25, that would be an outlier as well. Anything above 13.25 would be an outlier. All right, so if you want to check for an outlier, what you're going to do, you are going to do is Q1 minus 1.5 times the IQR, and you're also going to be doing Q3 plus 1.5 times the IQR. Right? Anything lower or higher than those values will be outliers. right? I should specify actually anything lower than that number is an outlier, anything higher than that value is an outlier. And one more example. So if you haven't done this yet in your calculator, please try this example, right? One more example. Again, I just want you to get the feel of typing in this data into your calculators. Go nice and slow when you type in your data because people make mistakes, right? You might type a 44 instead of a 4. You might type 11 instead of a 1, right? You might miss a number. It happens, all right? If your data doesn't seem to be looking right, just try it again. All right, so I'm going to go to my calculator again. All right, so example 2, a local marketing company did a survey of 30 households to determine how many devices the household contained that could show videos. I am sure this was a long time ago, but number of screens capable of watching video is probably way, way, way higher now in 2020. But Atlas and spreadsheets, I'm going to say screens. I'm going to call this screens. Do not forget to name this. And why is it not letting me type screens? What is going on? Okay. Screens, and then we're going to type in all the data values. Right, they surveyed 30 households, so I better end up at cell 30 when you type all of this in. But we got 0, 0, 1, 2, 3, 4. We got 5 ones. We got 3 twos. We got 1, 2, 3, 4, 5 threes. We got 1, 2, 3, 4, 5, 6, 7. We got 8 fours, I think. 1, 2, 3, 4, 5, 6, 7, 8. Then we got 1, 2, 3 fives. We got 2 sixes. And we got an 8 and a 10. So I typed that in slow and carefully, and I ended up with 30 cells. So that looks good. And before I actually do number 6, it says, using the data above, would you expect the mean to be greater than, less than, or about the same as the median? So let me actually go back to my iPad for a second. I think this looks a little bit close. It might be hard to tell, but if I had to guess, I would probably call this skewed right, just because of these 2 higher values. Yeah, I'd give you something a little more obvious or a little easier to tell, but if I had to guess, I'd say because the tail seems to be looking to be on the right side. If the tail's on the right side, it means these values are going to pull up the mean. So I would guess the mean would be greater. Is greater. And my explanation is it looks to be skewed right. So let's find out if that is correct. That's just a guess. So back to calculator. All right, so hopefully you know what to do by now. You hit Control-Doc, add a page. To get the 5-number summary, we add a calculator page. Go to Menu, Statistics, Stat Calculations, 1 Variable Stats. All right, if you missed any of that, slow down the video, watch that again. And we just go to X1 list, we add screens, and you hit OK. So the average, remember, was this guy. Average was 3.4, 3333. And our median was 3.5, so I was wrong. So yeah, this one is, it looks kind of skewed right, but I guess because we have more of those ones on the bottom, that actually pulled down the mean more than the 8 and the 10 pulled up the mean. So again, I would not ask you something like this. This is not skewed right or skewed left or symmetrical. It's just kind of random-ish looking data. So I guess there's more ones that pulled it down. So yeah, doesn't matter. I wouldn't ask this first question. So don't worry about number 6. But anyway, the minimum value was 0, first quartile is 2, median is 3.5, Q3 is 4, and the max is 10. Right, and the mean, the average was 3.4333333. So coming back to this, like I said, for number 6, I was wrong. But again, I wouldn't ask a question like that if it's not clearly skewed right or skewed left or symmetrical. And is 10 an outlier? Is 8 an outlier for this data? So I'm actually going to do this by hand. So is 8 an outlier for this data? Before I do my box plot, I want to figure out if I have any outliers first. So the easiest way to do this, by the way, is to use your calculator. But if I ask you to justify any outliers, you need to show the calculations. So that is what I am going to do here. So I had someone with 8 screens capable of watching videos and someone with 10 screens capable of watching videos. And I am asking, is that 8 an outlier? So show the calculations to support your answer. Remember that an outlier is an observation whose value is more than 1.5 times the IQR below or above Q3. So my IQR is going to be 4 minus 2, right? So my IQR is 2. Next, I do 1.5 times the IQR. 1.5 times 2 is 3. So I take Q3 and I add this number, 1.5 times the IQR. So Q3 plus 3 is equal to 4 plus 3, which is equal to 7. So the answer is yes, right? X equals 8 is more than Q3 plus 1.5 times the IQR. Right, 1.5 times the IQR plus Q3 was equal to 7. 8 is more than 7. So that means both 8 and 10 are outliers. These are outliers, and we have shown that, right? See number 8 for the calculations or the justifications. So if you did this on your calculator, you would have seen dots at 8 and 10, representing that those two values are outliers, which means my next highest maximum value is 6. So that is the max value I include for my box plot portion. Minimum at 0. Q1 is at 2, just my whisker. My median is at 3.5. And my Q3 is at 4. So actually, when I get rid of these two outliers, you can actually see, if you just look at the box plot portion, yeah, it actually looks skewed left now, doesn't it? Right? Doesn't this look to be a little bit of a longer tail on this side? And this section of the box looks to be more spread out than that section. So maybe that does justify the mean being lower than the median. But again, I wouldn't ask something like that unless it was very clear. So what do you think is a typical number of screens for a household to have according to the data? Explain. Well, yeah, I don't like this question because, again, it's not really clear what kind of shape the distribution is, right? But if the distribution were clearly skewed to the left or clearly skewed to the right, then you would say you would use the median. The median would be a better representation, right? But this one was not too clear, so ignore that question. And that is going to be it for today. So main ideas for today is know how to calculate an outlier by hand, right? So an outlier is anything more than 1.5 times the IQR, lower than Q1 or higher than Q3. And please also know how to use your calculator to do stuff like get your 5-number summary, to find the mean, and to also graph a box plot and a dot plot on your calculator. Right? We should also be able to do all of those things without a calculator, right, by hand, right, by organizing the data from least to greatest to find the median, then find a median of the lower half and the upper half to get Q1 and Q3. Right? These are all things we should be able to do by now. If any of those things sounded like things you could not do, then you need to rewatch a previous video or ask me a question about what you have. But hopefully nothing so far has been too crazy, right? Make sure you are keeping up with the notes each day, and I will be seeing you guys on Friday. All right, so see you guys. Take care. Stay safe. Bye-bye.